Let us start with the first question. The sum of the coefficient of x to the power 2 by 3 and to the power minus 2 by 5 in the binomial expansion of this is. So simply, again a very easy question, we can simply just write down first our general term, which is TR plus 1. How do we write it down for here? NCR x to the power n minus r. And what is my x here? X to the power 2 by 3 to the power n minus r, y to the power r. And what is my y here? 1 by 2 x to the power minus 2 by 5 to the power r. Now let us try to segregate all the x terms together and take out all the constant terms to the one side. What are we going to left with? In 9CR, here we would also have 1 by 2 to the power r, and x to the power, what is the power of x going to become? This would basically be 18 minus 2r by 3, and this would be, and at here on the other side, what are we going to have? X to the power minus 2r by 5, or this can be simply written down in below. This would be upon x to the power 2r by 5. And if I remove this from here as well, what am I going to be left with? Minus 2r by 5. So simply if I take the LCM, what am I going to be left with? 18 5s are, what do we get 18 5s are to be? 90, sorry, 18 5s is going to be our 80. 18 5s are would be 90 minus, this would become 10r minus, and this would become 3 2s are 6r. So from here, what do we get? 90 minus 16r by 15. Or we can simply write this down as, or let us leave it in this way only. What does our x to the power become? This becomes 90 minus 16r by 15. 16r by 15. So this is our general term for the entire equation. Let us remove all this portion. So we get our general term in this format. Now what are they asking us? We have to find out the coefficient of x to the power 2 by 3. Now if I were to make this entire term 2 by 3, that means 90 minus 16r by 15 would be equal to 2 by 3. Let me cancel things out. This would become 5. Here we would be left with 10. So 80 would be equal to 16r, and from here r I get to be 5. So I've gotten the value of r for the first term, which is x to the power 2 by 3. Here r is equal to 5. Now let us find out the value of r for this one. For here we have x to the power minus 2 by 5. We have to find out this coefficient. That means I would say 90 minus 16r by 5, sorry 15. This should be equal to minus 2 by 5. So from here simply this cancels out 3 times. Here we would have 6, so 96 would be equal to 16r, and from here we get r to be 6. So we've gotten our r. Now what have they told us? We have to find out the sum of coefficients of r is equals to 5 and r is equals to 6. And what is our coefficient? Basically this portion here. This is our coefficient. So let us find out the sum. So our sum would be equal to, first at r equals to 5, this would become 9c5 1 by 2 to the power 5 plus 9c6 1 by 2 to the power 6. So upon solving this, what are we going to get? We have, let us take 1 by 2 to the power 5 common. We are left with 9c5 plus twice of 9c6. And upon solving this entire equation, what are we going to get? 21 by 4 as our answer. If let's say I was to show you this by opening it up, how am I going to open it up? 9 into 8 into 7 into 6 into 5 upon 5 factorial 3 into 2 plus this would become 2 times of, I can open this up as 9 into 8 into 7 upon 3 into 2, because NCR is equal to NC n minus r. So I've opened it up in this way, and if I try to calculate this, 3 2 cancels 6, 5 cancels 5, 4 cancels this twice, 3 would cancel this 3 times, 2 and 2 would get cancelled out amongst each other. So from here we would be left with 7 2s are 14, 14 into 7, we get 126 plus, and here we would be left with 7 8s are 56, 56 into 3 we would get 8, 15 and 1 16. So from here, and then this would entire thing would be divided by 2 to the power of 5. Upon solving, we are going to get our answer to be 21 by 4. So this is how we solve our question. Now let's look at another one. If the term independent of x in the expansion of this is 105, again we have to use the same concepts. Now I hope you must have seen that since there are not too many concepts to ask from in this chapter, the direct questions that are asked are all based on finding out the coefficients of x or anything. So again, let us do the same thing. Let's first write down our general term. Our general term is going to be tr plus 1. N is 10 cr, x to the power n minus r. What is our x here? Root a x square to the power 10 minus r and y to the power r. So this becomes 1 by 2x cube to the power r. Now we have to find out the term which is independent of x. So first let us segregate all the constant and variable terms together. So we would get 10 cr root a to the power 10 minus r and 1 by 2 to the power r. And what are the power of x going to be? It is going to be 20 minus 2r here, and it would become minus 3r here. So we would have 20 minus 2r minus 3r. So this would become 20 minus 5r basically. So here we would have 20 minus 5r as the power of x. Now, since we've segregated all these terms, now what do we have to find out? We have to find out the term which is independent of x. So that means the power of x has to be 0 if we are finding out the independent term. So we can say that 20 minus 5r should be equal to 0. And for this, our 5r becomes 20 by 5, which becomes 20, and our r becomes 4. So for 4, our term is independent of x. So let us find out the term which is independent of x. So this is basically our term which is going to be independent of x. Let us solve it here. We have 10c 4 root a to the power 10 minus 4 would become 6 and 1 by 2 to the power 4. And they've told us that this value is equal to 105. Now we have to find out the value of a square. So let us try to solve this entire equation. We are going to get 10 into 9 into 8 into 7 upon 4 into 3 into 2, 4 into 3 into 2 into, here we would be left with a cube, and this would become 1 upon 2 into 2 into 2 into 2. Let us open this up so that our calculations become easier, and this is 105. So from here, 1 2 3 2's gets cancelled out with 8, 3 gets cancelled out this 3 times, 2 cancels this out 5 times, 5 cancels this out 21 times, 7 cancels this out 3 times, and so in the end what are we left with? A cube, sorry, this 3 and 3 also gets cancelled out, so what are we left with? A cube is basically equal to 4 into 2, which makes it 8. So our a becomes 2. That means we have to find out the value of a square, so it becomes 4, and this is our answer. Again, very easy question. The same concepts we are using again and again. Now let's look at another question. The sum of all rational terms in the expansion of this is equal to, again the same concept repeated. First let's write down our general term. It would become ncr. What is our n? 15 cr. What is our x? 2 to the power 1 by 5. This would become n minus r into y to the power r, and what is our y? 5 to the power 1 by 3 r. So let us take all the 2 and 5 terms together. So we would be left with 15 cr. This would become 2 to the power 3 minus r by 5, and here we would be left with 5 to the power r by 3. Now of course, for we know that for this entire term to be rational, we must say that 3 minus r by 5, 3 minus r by 5, where r is, of course, we know one thing about r, is that r is less than 15, less than or equal to 15, and it is greater than equal to 0. So from here we can say that r minus 3 by 5 and r by 3 should belong to integer category. If that is the case, that means this entire term would become rational, right? So From here, what can we say is that r by 5 and r by 3 should be satisfied, because if I, let's say if I take the maximum value of r also, this entire term, would it be negative ever? No. If I take r to be 15 also, it would become 3 minus 3, which makes it 0. So it would never become 0. That means we are at least over in that situation. So from here, that means these two has to be always satisfied. So what we can say, that r has to be a multiple of 5 and 3 together. That means r has to be a multiple of 15. How, when can r be a multiple of 5 and 3 together? When it is a multiple of 15. So what are the possible values of r? So the possible values of r becomes 0, 15, 30, 45 and so on. But we know that r is always less than equal to 15, because our n value is only less up till 15. So what does the possible values of r become? It become 0 and 15. There are just two values possible for this equation for us to get rational numbers. So we are just simply going to add. They've told us to find out the sum of all rational terms. So let us put the values of r equal to 0 and 15 and find out the sum. Now here there is, of course, we have to take the entire term, because they've told us the sum of all rational terms and not coefficient. So let us find out the sum of all terms. We are going to get 15c0. Let us take r to be 0 first. This would become 2 to the power 3, and here we would be left with 5 to the power 0, which makes it 1. Another one would be 15c15, 2 to the power. Once I've taken r to be 15, so this would become 3 minus 3, 0. So 2 to the power 0 becomes 1, and I would be left with 5 to the power 15 by 3 makes it 5. So this is my answer. So upon solving this, what do I get? This would become 8 plus 5 to the power 5. Of course, it's going to be a very big number, and if you try to solve this entire equation, you would get 3133 as your answer. This would be your answer. So that is how you solve questions of general term. Again, we found out the general term and used the same concepts that we have been using it from the first lecture. So again, by this you must have understood that remembering the general term is very much necessary in such type of questions. Let's look at another one. Now this question was a good one. It was asked in 2023. This was a good question that was asked by JEE Mains of multinomial theorem. A plus bx plus cx square whole to the power 10. So whenever we have multinomial theorem, one thing that we can clarify from this is that our n is equal to 10 and k is equal to 3, because we have 3 terms and k used to be the number of terms. This is equal to some value, and they've given us that p1, that means when the coefficient of x is 1, x to the power 1, that time the value we are getting is 20. And when p2, that means when we are finding out the coefficient of x square, that coefficient of x square is basically 210. Then we have to find out the value of a plus b plus c. So simply again, let us write down the general term of a multinomial theorem. We had studied how we can find out the general term of a multinomial theorem. It is simply written down as n factorial, which is my 10 factorial, upon r1 factorial, r2 factorial, r3 factorial. I have 3 basically terms, so it would go up till 3. And here I would have x1 to the power r1. So what is my x1 here? A to the power r1, bx to the power r2, and cx square to the power r3. So let me segregate all the constant term together and the x terms together. So from here, what am I going to get? 10 factorial upon r1 factorial, r2 factorial, r3 factorial. And from here, after segregating all the constant terms, we would be left with a to the power r1, b to the power r2, and c to the power r3. So these are all my constant terms segregated together, and I would have x to the power r2 plus 2r3. Now, I hope you all remember, in multinomial theorem, we have to choose r1, r2, r3 in such a way that their sum is equal to 10. That means first condition that I have here is r1 plus r2 plus r3. This is equal to 10 always, which is my value of n. So if this is my first equation, and we have to find out C. Now in this entire equation, the x term has been segregated. If I look at this summation here that has been provided to me, xi, x to the power I, has been taken out separately, and pi has been taken out separately. That means this entire term, this is my pi. And they've told us that p1 is equal to 20. So let us make two cases here. Case 1, when my I is equal to 1, that means my p1 is equals to 20 and my x has to be to the power 1. So what would I say is that r2 plus 2r3, this should also be equal to 1. And what are the values? Now this is my second equation basically. Now what are the values of r1, r2 and r3 that would satisfy my first equation and second equation? Because we are talking about these two equations, my first equation has to be satisfied at all times, of course. In my first case, this equation also has to be satisfied once again, my second equation. So what are the values of r1, r2 and r3 that will satisfy both these equations? It is, of course, now we remember that r1, r2, r3 can be only whole numbers. It cannot be any fractional numbers, or it cannot be never negative numbers. So from here what I can say is that my r3 has to be 0, my r2 has to be 1, and if this is the case, then my r1 would be equal to 9. This is the only case that satisfies this entire equation. So from here, if this is the only case that satisfies my equation, what is my p1? P1 is equal to 20, and if I put the values of r1, r2, r3 as per these values that I got, what am I going to be left with? This would become 10 factorial a to the power 9, b to the power 1, c to the power 0 is just 1, upon 9 factorial, and 1 factorial, 0 factorial of course is just 1. This is equal to 20. So this is what I'm left with. Now simply I can take out 9 factorial and 10 factorial. If I cancel it out, I would be left with just 10, and 10 would cancel this out twice. So I would be left with a to the power 9, b is equals to 2. So this is one of the equations that I've gotten. Now let's take our second case. What is in my second case? Second case, I'm taking I to be equal to 2. That means I'm finding out the coefficient of x square. And here my p2, what is my p2 is equals to 210. Now if my p2 is equals to 210, that means what I'm saying is that r2 plus 2r3, this should be equal to 2, because I'm finding out the coefficient of x square. So I have to make this entire term to be 2. This entire term to be 2. So this is my third equation here. Or let me put this as 2 dash. This is my 2 dash equation. Now I have to find out the values of r1, r2 and r3 in such a way that it satisfies my 2 dash and 1 equation. So what are the values of r1, r2, r3 that can satisfy this? Let's say if I take r3 to be 0, r2 has to be 2, and this would become 8. If I take r3 to be 1, r2 would have to be 0, and again this would become 9. So again, these are two values. Are there any other values that would satisfy this entire equation? No, there are just two values that basically satisfy these two equations. So from here, what now I can say that my coefficient of x square would be the sum of these two cases. I have to take, this is my first case, let's say this is my first case and this is my second case. So my coefficient would basically be the sum of these two cases. So let us put the values. I would get 10 factorial a to the power r1, so a to the power 8, b to the power r2, b square, r3 0 upon 8 factorial 2 factorial plus 10 factorial a to the power 9, and b to the power r2 is 0, so it would become 1, and I would be left with c upon, this would become 9 factorial. 0 and 1 factorial are always 1, so this is equal to 210. Now let us try to simplify this entire equation. I can simply take out my 8 factorial common from both these equations. I would be left with 10 into 9, and I can also take out 10 common, so from here 21 would be left. So this would become 9a to the power 8 b square upon 2 plus this would become a to the power 9 c is equals to 21. And if I take 2 common here, so this would become 2 and 2 would be removed from here, this would become 42 basically. Yes, so this is my second equation that I've gotten about a and b. Now of course there hasn't been any other information provided in the question through which I can at least form 3 equations, because I have 3 variables here, a, b and c. So what you have to do in this question is you have to use hit and trial method. So from here I have first equation to be this, and what is my second equation? 9 a to the power 8 b square plus 2 a to the power 9 c is equals to 42. So these are my 2 equations. Now I have to choose the values of a, b, c in such a way that all these 3 equations are satisfied. And of course a, b, c, first I will choose a, b, c to be whole numbers. They have told us a, b, c belong to natural numbers, so one of our problems from there has been solved. A, b, c, since they are natural numbers, that means what I can do is I can simply use hit and trial method. Now let's look at the first equation, a to the power 9 into b is equals to 2. Now if a, b, c, all these 3 are natural numbers, that means a has to be 1 and b has to be 2. Only then this equation would be solved. Or what can happen is a to the power 9 should be equal to 2, but then a would be equal to 9th root of 2. However, that is not possible because a has to be a natural number. So from here, from the first equation, what have we gotten? That a has to be equal to 1 and b has to be equal to 2. Using hit and trial, we found this out. Now let us put the values of a and b in the second equation and find out the value of c. This becomes 1, this becomes 4, 9 4s are 36. This gets subtracted, 42 minus 36, this becomes 6. From here we would have 2c is equals to 6, and from here c would all come out to be 3. So this is how we've calculated our values of a, b, c. A is 1, b is 2, and our c is 3. Now what have they asked us? We have to find out twice of a plus b plus c, twice of 1 plus 2 plus 3. What does this come out to be? Twice of 6, and this is nothing but 12. This is our answer. Again, the only thing that we majorly did here was first find out the general term, and then the question was of course a bit lengthy here because we had to check all the cases and then find out which case satisfies our equation, and then in the end also we had to use hit and trial method. So this question definitely was a very lengthy one. However, it was a very easy one because the concepts of binomial theorem that we used here were simply were of general term and multinomial theorem. So simple question. Let's look at one more question. If the coefficient of x to the power 4, x to the power 5 and x to the power 6 in the expansion of this are in arithmetic progression, then the maximum value of n is. Again, very simple question. We remember how the expansion of this used to happen. It used to be 1 plus x square, sorry, this used to be nc0 plus nc1x plus nc2x square plus nc3 x cube plus dot 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 dot, this goes up till ncn x to the power n. And what is the general term in this equation? The general term of course is ncr x to the power r. So if my general term is this, I have to find out the coefficient of x to the power 4, 5 and 6. That means what would my coefficients basically become? For x to the power 4, let me write it down this way. My coefficient would be nc4. For x to the power 5, my coefficient would be nc5. For x to the power 6, my coefficient would be nc6. Now they've told us that these 3 are in arithmetic progression. That means from arithmetic progression, if let's say nc4, nc5 and let's say nc6 are in arithmetic progression, we can say that this is a, b and c. And from arithmetic progression, we remember this property, 2b was equal to a plus c. So let us use that property here and find out our value of n. So this would be twice of nc5 is equals to nc4 plus nc6. Let us try to open this up. What do we get? Twice of n factorial upon 5 factorial n minus 5 factorial. This is equal to n factorial upon 4 factorial into n minus 4 factorial plus n factorial upon 6 factorial n minus 6 factorial. Now how can we solve this? First of all, we can see that n factorial is common in all the three terms, so simply they can get cancelled out. We can see that we can take out n minus 4 factorial common from both the sides of the equation and 4 factorial from both the sides of the equation. So what are we going to be left with? I have taken 1 by 4 factorial n minus 4 factorial, sorry, I've taken 4 factorial into n minus 6 factorial to be common from both these sides. So what am I going to be left with? This side I would be left with 2 upon 1 5 into n minus 5, because of course n minus 5 is greater than n minus 6, and this would be equal to, I've taken again 1 by 4 factorial n minus 6 factorial to be common. So what am I going to be left with here? This would become 1 upon n minus 4 into n minus 5 plus, and here I would be left with 6 into 5. That's all. So from here this and this gets cancelled out, and now let us simply cross multiply our equation and let's see what do we get. 6 5 is 30 and 32 is 60 times of n minus 4 n minus 5. This is equal to 5 times of n minus 5. So let us simply just open up this entire equation. We would get 60, or let us cancel 5 with each, oh sorry, this wouldn't be this equation because we have a plus sign here. So now let's say if I was to cross multiply this entire equation, what would I get? This would become twice of 6 5s are 30, and here I would have n minus 4 n minus 5, and this would be equal to 5 into n minus 5. Now here I would have, since this was a plus sign, so I would have 30 plus n minus 4 n minus 5. This is what I'm going to get here. Now if I solve this entire equation, simplify it more even further, what am I going to get? If I cancel this 5 with 30 and then multiply all my terms, at the end what am I going to get? N is square minus 21n plus 98 is equals to 0. I'm directly writing it down, not wasting much time, because you can obviously calculate it. Very easy calculation, simply multiplying all the terms and then taking out all the common terms, cancelling it. And now once you've gotten this equation, what have they told us? We have to find out the maximum value of n. So how can we find out the maximum value of n? Let's say if our y is equals to n square minus 21n plus 98 is equals to 0. A quadratic equation we had studied. Let's say if any equation has been given to us and we have to find out the maximum of that term. So how do we do? That means we can simply first differentiate this entire term and then equate it to 0, and for the value of n for which we would get our equation to be 0, for that value of n, our n would be maximum. So simply dy by dn, let's make it 0. So this would become 2n. Of course you haven't studied differentiation much, but you at least have an idea as you had studied a little bit of differentiation in physics. So that is what we are using here, differentiating this entire equation in terms of n. We would get minus 21 is equals to 0. From here we would get n to be 14, and so this becomes our answer. So this is the value of n for which we would get the maximum value of this entire quadratic equation. So that was all for this chapter. Again, I would repeat, you must understand the theorems and the general terms that were used in this chapter, because as you saw in the previous year questions, mostly questions that were asked were all based on general terms. If you are able to write down the general term and you are able to find out the difference between the coefficient and terms, you would be able to solve the questions very easily. Thank you.